Hello and welcome to IT Security Labs, and thank you very much for joining me tonight. We have yet another live stream where we are going to be learning ethical hacking. In this series, we learn ethical hacking, but above all, we actually try to understand how does detection work when we actually hack a machine. So today we are going to be trying to complete a machine from VownHub. This one is called Django 101. It's a very easy machine to exploit. Our main goal here is to end up getting a root flag. But as we do that, if we were doing this in a real network in the real world, what kind of detection gets triggered? What kind of alerts do people see when this happens? And that's really our goal here, is to understand, okay, what kind of alerts are we going to trigger as we do this? And what does the traffic look like? Because let me be honest with you, it's very useless of you to go and complete a lot of capture the flag machines and just think that you're having fun, and you have no idea what that looks like for the defenders. You have no idea how to actually defend on what you're doing. So the goal here is to learn to be ethical hackers and to do it very well, but also to know what the work that we're doing is, and also know how to defend against what we're doing. If you're interested in that, you are in the right place, because right now I downloaded this machine here on VirtualBox. It's working and it's on 192.168.38 on 171. So the first thing that we need to do is let's enumerate and find out what's running on this machine. So nmap is a tool of choice here. Nmap minus sv minus sc 192.168.38.171. This is going to scan the top 1,000 ports, top 1,000 TCP ports. This has nothing to do with UDP. It will not scan all 65,000 ports. And it's good to see everybody who is here. BT, Coffee, and Fidausi. It's good to see you, gentlemen. Thank you all for joining me tonight. This is wonderful that you are here, and I'm very excited that you decided to join me today. So as you can see, we first see port 21 FTP is open. As always, as a rule for myself, if I see FTP, I gotta go and try it. So we go and try with anonymous user. That's what we just do. FTP 192.168.38.171. We just have to try it. Sometimes Nmap will tell us that anonymous will work with on FTP. Sometimes it doesn't. In this case, anonymous doesn't work. So we know FTP server, which is a file sharing service, is there. We'll keep that one in mind. In fact, I'll put it in my notes here. Just in case I get too fascinated, I'll still want to come back to FTP. All right, so FTP was there. It's not really helping. We have port 22. That's also not too helpful. What you are going to observe right now, right away from port 22, is that we are running Ubuntu. And with this version of OpenSSH, we can actually determine the version of the operating system, like whether this is Ubuntu 18 or 20. In this case, this looks like it's 18 from this 7.2 here. So you can use this to determine the version of the operating system. And there's a way you can just go and look it up on any website out there that will tell you. But we are very interested in this port here. It's port 80. So it's saying, hey, we do have a website and it's running. So what are we going to do here? Well, first, it did the work for us. It says it found a /site. That's interesting. So let's just go to that website. If you go to a browser and just visit our site here, HTTP 171, and sure enough, here's our site. Makes sense for us to just click there. And it says, oh yeah, start Bootstrap. Doesn't say much, but this is part of the enumeration process. This is you interrogating the system, trying to figure out what is it going to tell me. One of the things you can do is view the page source. In the page source, we are looking for comments We're looking for any version of the system. People usually leave comments here that are interesting, and at the bottom here you usually see, like, powered by. Sometimes you'll be able to see. In this case, this page source is pretty much not talking, so we'll close it. All right, I guess it's time to poke around. Before we move on, we gotta interact with this thing. I'll click on the logo here. Okay, get started. What does it do? Get started just takes us to, it looks like a default page. There's a subscribe page here. You can check for like things like cross-site scripting and other things like that. We see a phone number. You might try to call that. We do not have emails here, which is kind of interesting, but we have a phone number, which I think is just a default template phone number. We don't see anything in the getting started. All right, so about, I think, that was part of that. Projects, bus car. Okay, now that they're just messing with me. Bus car gives me a blank page. Here's the page source. What is this bus car thing doing? Nothing. It's not talking, but it leaves me with a equal sign. I mean, I'm an attacker after all. This thing literally just says equals to. I go straight to local file inclusion. So I just type a Linux command ls. Oh, so this talks. So this is an easy thing. Okay. Whatever this is, I can run commands. ls-l. Oh, actually, I can do more here. So I'm going to go to town here. Let's take this to Burp Suite. Burp Suite is better at this than just running it in the browser. So what we're going to do is we're going to shift from a browser to Burp Suite, so we can actually visualize this better. So let's close this. So Burp Suite, you use it to interact with web applications, and in this case, we visited the same exact URL in Burp Suite. We type the command ls. So first, let me turn the intercepting off and on again. So when you first visit the same URL, type the command ls that you just saw me type. This is what you get. Then let's refresh this. Now we get a copy of that in Burp Suite. So what we're going to do is we're going to send this to Repeater. And Repeater is going to allow us to really mess with it even more. So let's do a pwd, print working directory, please. I like this because with Repeater, I can just keep repeating the same command here over and over again without refreshing a browser. Okay, so it's saying I'm in the site. All right, so let's do something like ls-l. What's inside of site? Okay, so it doesn't like when I do ls-l. Weird enough. Oh, it's playing games with me. Let me URL encode this. Usually when you go and you encode things work better. So URL encode all characters. I really want, yeah. Oh, now it talks. So this thing likes it when you URL encode. Browsers will URL encode for you, but in this case, we see that we do have WordPress. That's good. So I'm not going to even waste any time here. I'm going to straight to try to read the contents of WordPress.config file. Config. Let me show you the file that I'm talking about. I was going to say. So let's ls/WordPress. The Fun thing is, after today, you're going to learn exactly how to URL encode because I have to do this several times. So we go to convert selection, URL, encode all characters. Let's send it. I didn't want to go back to the browser, but ls. Okay, so in WordPress, we have a config.php. This is a notorious file that you know comes with credentials. So let's forget, I don't know, URL encoding is not working for me. So I'm going to say, instead of ls, I'm going to say cat WordPress config.php. That's the file that you just saw there. It looks like it's a blank thing here, but let's view this page source. It's actually not blank. So you always want to view the page source if you can. In this case, here are passwords and credentials. So we are looting here already. I don't care about that. Oh, this is just noise. All right, so this is interesting stuff. Database and username and password. So what is the first thing that you do when this happens? You take these credentials and you go and try to FTP. You try to SSH. But we're not done yet with our enumeration for now. Let's go back and pwd. So we're in the HTML site. What if we go back one? Meaning if we go down here. Because we have to finish. Is this the only website or are there more websites? Okay. So it looks like it's the only website, but you might have noticed that I just did an ls-l, ls-la will actually list hidden directories as well. And in this case, this was very important that we do that. Without this, you would not have found out that we do have a file called backup. So let me... Wait, I don't know why I did. Let me just do ls-a. There's too much noise here. Okay, so I have this PHP, WordPress, -la. I thought I saw a backup file somewhere here. Maybe there isn't. Let me see. Oh, ls-la in the HTML directory. Okay. So if we look in here, we see this .backup file. So we're going to open that file as well. So we're going to just say, can we cat that file? It's a .backup. It's a hidden directory. So ls-la would have worked in that directory. So cat this hidden backup directory. We want to make sure that this actually makes sense. All right, so I'm just going to view this in page source following BT's suggestion because it looks nicer. So it looks like we have a backup of the same credentials. So I'm going to copy this. Got my notes. Remove all this. But notice what happened here. This person thought they were very clever. The username is now Django01 instead of this one. The password was kept the same. They changed the username. So we now have two credentials with the same password. this username here and this username right here. So that's where we are right now. And we just looted this by just simple enumeration. We didn't actually like mess with anything. We're like, okay, let's just get this username and that password by also enumerating. So we can go back here and do the same thing one directory down. So we can actually finish our enumeration. ls-l. Instead of HTML, let's look in the www directory. Okay. Can I just look in the home directory? Let's view it in the page source. All right, so this is our home directory. We most likely won't be able to mess with any of these, but at least we are able to see stuff. ls-la. Look for any hidden directories. Okay, so it looks like this is just a regular Linux system. This script here looks interesting, but it's owned by root, so we won't be able to do much here with this script. But this is how we enumerate by hand without GoBuster, without any other tool, just to be able to see. With this in mind, we have credentials, so we might as well start using them. We'll come back to Burp Suite in a little bit here. But let's use our FTP. I'm just going to go to my temp directory. I have a secret.txt message that I'll try to put in there. So let's try to FTP again. This time, we're going to use this Django that was in the backup. And this password. Okay. ls. So we see HTML. We already know what's in here. ls-l cd HTML ls. So it's the same information that we already know about the WordPress, CSS, and this PHP. Maybe I'll just steal this file here. Since this is the one that we're interacting with, maybe I'll try to see if this will actually give us any information about how it's doing things. There is nothing to steal in the WordPress. We already got the credentials that we need. JavaScript, maybe if we get really desperate, we start interrogating JavaScript. But for now, we are fine. So we'll just exit. Let's do okay. It's doing nothing really other than that. So as an attacker, I'm lazy. I'm just going to borrow. I'm borrowing what they gave, and I'll reuse the same thing, but with just a different word. I'll change this to hacked. I just want to see if this will actually work. Okay, now I have my own hacked.php, so I could have renamed this. Now let me see if I can put that in the FTP server. All right. There is no real reason for doing this other than to try to mess with the site, because I already have command execution on the browser. I just want to see if I can. Okay. cd site. Where am I? Okay. They have their own here. I'm going to put my own. Ha, they are clever. So there is a filter that will not let me put PHP files this way. That's the good part is there is a filter that will stop me from doing it. I wonder if I could do a wget through the browser. That's another option, right? You can run wget or other things. But for now, this FTP server is proving to be useless. And by the way, are we actually generating any alerts from all this noise that we are doing already? Let's find out. We're checking our intrusion detection system. We have a Wazuh agent installed on that server. We are also detecting network traffic. So we will be interested in seeing what's happening here. All right, this is probably us failing to sign into FTP. All right, I see source IP was us. All right, so yeah, that was us when we tried to sign in as anonymous. So our intrusion detection system is capturing us as we do this. And this is by far is why I do these live streams, is because I want to see what does it look like when I fail to sign into an FTP server when the host is being monitored by a host-based intrusion detection system or any other client, really, like even an antivirus, see if it actually catches us. In this case, we generated a lot of alerts by just failing to sign in this case, with FTP. All right, so let's forget that FTP. Let's get to the business here. I am just interested in getting a reverse shell. So let me go to payload all things. I don't want to waste too much of my time and your time. Let's go to payload all things. Let's get a reverse shell going here. So for that, here's payload all things. So we can shop here. This is a website where you can go and get different payloads for getting a real shell on the system, a reverse shell. Unless or otherwise suggested, I always start with the obvious, bash TCP. And I would take this one. So let's construct our command here that actually works. Or first, this is not our IP. It's 192.168.38. We need to find our IP for our Kali Linux. So let's get out of here. IPA. And we're at 186. So we come here and we put .186. All right. Let's leave the port the way it is for now. And while we're still at it, the best way to do this is to put this in quotes, especially if you are trying to get from a command execution. This should be executed by bash. We can ask this thing, hey, where is your bash, by the way? Oh, he says, oh, by the way, my bash actually lives in bin bash. So we're going to use bin bash. Hey, bin bash, can you execute this for me? So that's what I'm going to do. I'm going to say, hey, let's call bin bash to execute bash for the reverse shell on port 4242. I will copy that. I'll just start the lazy way. We might have to go to burp suite to actually properly URL encode this. But for now, uh, 4242. All right. If that works, that didn't work. If it fails immediately, you know it didn't work. It didn't work. So burp suite to the rescue. So I'm going to copy this. We might have to go back to consult burp here. All right. So now with that, we have it in burp. Let's try to URL encode it. This time, I would like to encode all the characters. Because the browser does the bare minimum, burp will do the actual work. All right. Oh, come on. All right, let's do it again. I needed to make sure that there was a space here. And then URL encode that. And send. Nothing happens. Let's check here. We got a reverse shell. I have to warn you though, if port 4242 doesn't work, please let me know in the comments actually. What do? You use port 4242, 444, and all those random ports. If that doesn't work, what is the logical thing that you should do as an attacker? I actually kind of modified this machine. I forgot to put it back, but port 4242 by default, if you just download this machine, it will not work. If you download it from here, it will not work. There is a firewall, the UFW firewall, that will block you. But let me know in the comments, if 4242 doesn't work, what should you do? Let me know about that. Hey, Syntax. Thanks for joining. All right, so as you can see, we are in. We just need to stabilize this shell. By that, we stabilize it with Python 3, I think, was which. Python, it doesn't exist, but Python 3 does. All right, let me make sure that I can actually clear my screen. Export term. Why am I even bothering? I'll show you here. My reverse shells. This is how I usually make sure that I'm very fast. It's because I already have everything documented here. Yes, thanks BT. So if you try to get a reverse shell on some random port and it doesn't work, it doesn't mean that you don't have working exploit. People who do like the OSCP and things like that, those certifications, that's how they get you. They will have UFW. This thing here can have some rules that will actually be blocking you. So always use port 80, port 443 if those don't work. Okay, so I'm in as www.data. www.data doesn't have a home directory. We really don't care about www.data. We actually want to try this user as well because credential reuse is a real thing. So let's switch user to Django using the same password. All right, now that we're in is Django. The first thing is sudo -l. Can we run anything as sudo? This should not have any sudo privileges. In this case, this user may not run any sudo command. And if you do like sudo cat /et pass wd, this event here gets actually logged that you try to do that. And as you can see, you will be reported. When we go back to our intrusion detection system, our security onion, we should be able to see this. This is actually recorded right now that we actually messed up. So if you're doing a pen test or an engagement for a customer, maybe don't do silly things like this, because you'll be reported. And maybe you want the customer to catch you so that they actually react to events. But either way, that is something that will be reported. So if you do an ls, just ignore these two files for now. They will not be there. But we do have user.txt. All right. So now that we have that and we see that it's actually kind of working, let's see how do we go from here. The first thing that I usually do is I want to be root here. So I go to my privilege escalation. In this case, I would like to look for SUIDs. So let me run this. Any files that have SUID bits here can give me an easy root access permissions. So you're looking at the permissions here. One of these will say S, but with better permissions. So this one belongs to Damon. We do have ping. We have abused ping before. This is the SUID bit that we're looking for. Let's see. This is only valid if you know what you're looking at. If you don't know, if you've never done this before, you'll be looking at this and be like, how do I know which one to try? Some of these are default on Linux systems. So this is not talking. All right, let's make our lives easier. Let's do it this way. Let's put lean peas there. I think it's spelled like that. I have lean peas in here. All right. So here's leanpeas.sh. This is a privilege escalation tool. I don't use it that often here because most of the time we're able to figure things out. In fact, in this case, we can figure out how to do things. But let's just put lean peas and let lean peas do the work for us to try to enumerate how can we get root. There's also another version called WinPeas for Windows. But for now, let's just get lean peas there. You know what? Why bother with a Python? Let's use FTP. .168.171. Let's use FTP to get our lean peas there. We already are there anyway. We might as well. So we're getting in as Django. So we want to put that in the user Django's home directory. I wonder if we can do it. Let's try. Okay, cd/home. Can I do that? Okay. cd Django. Yeah, we signed in as this user, so we should be able to. Let's look at that. So now let's put leanp.sh. Boom. All right, that was easy. So now if we come back here, ls, here's our leanpeas.sh. Come on. Let's make it an executable. Yes, okay. I might have to end this just in case it behaves funny here. But right now, this is how we're going to do it. I want to show you that LeanPeas actually is a tool that we can use. So LeanPeas right now is going through our system. It's investigating, hey, think of this like a a health check. It's checking what's normal and what's not normal. And also it is a database of common misconfigurations that it will give to us right now. It will be like, yo, these things here, it goes by super fast. It's a must if you're going for the OSCP, I'll tell you that, because you never know what's wrong with the system. And I actually kind of made a mistake here. You should save these results to a file, then read the file and search the file for interesting things. But as people who are using an intrusion detection system, I'm curious. My ideas, is it going crazy right now? Security Onion, because I'm running LeanPeas. Let's find out. Because LeanPeas is going to generate a bunch of alerts. Or at least I think it should. All right. Oh, by the way, this is our Nmap results. When we were doing Nmap, this is what Nmap generated. File deleted. Okay. First time user executed sudo. That was us. That was definitely us. Yeah, Django, when we typed sudo and we failed. Oh, actually, this was for audit D when we typed sudo. That was before the stream started. All right. So I tried, oh yeah, look at that. I tried to add audit D to enhance our Wazuh agent, and I just didn't get a chance to finish the addition, but of course, that will actually really help. Low relevance attack? What are you talking about? Let's check that low relevance attack. So if you have ever ran LeanPeas in your life and you're like, oh, does it get picked up by, IDS systems? We'll find out together here. Okay, that is loading super slow. All right. So here are the results that we found. It found the username and password that we already know. So thanks LeanPeas, but not really. We already know about this. But if we didn't know about these credentials, LeanPeas would have told us. So it's a very useful tool. Password secret for the debian.conf. I don't think that's going to help us. I hope I don't run out of memory space here. Here's another password. That was found. So LeanPeas will show you the passwords that you have. And the one in the WordPress config. All right. Let's keep scrolling. If you have any networks in there, that might be interesting. This will also show you right here. Let's keep going. I didn't save my results to a file, so I won't be able to search here, but usually you should be able to just save this to a file and search. It's a lot of output, but when you're going through an exam like the OSCP with 24 hours, this is nothing. you'll be very thankful that you have a tool that actually does enumeration for you. Oh, it did the SUID check here, so you notice that this is the same. These are the same results with interesting binaries like the @ binary flagged. Oh yeah, these are actually we do have a few here, few CVEs. So this one and this one. Local privilege escalation for that. Okay, I'm all for that. Okay, this looks like C code. Maybe I just need to use GCC and run it. I might be in luck here. I have a brain. I don't like to work too hard. I know it's CVE. I'm like, hey, did anyone ever use this before? Or apparently, on Hack the Box on Bucket somebody did, or Academy somebody did. One of these is going to show me how it's actually done. You'll be surprised how much time this saved me during the OSCP or other exams out there. But they are saying it should be here. Oh, somebody was running the same lin peas. So that one is not going to help me. Okay, using lin peas, we say that it's vulnerable to that, but it didn't test to run on the server. Oh, you're not helpful. Well, I'm going to test it. Let's do it. So let's roll this wget and use FTP to get it to our server. I'll likely do my temp directory. ls. So 281. That's a C code, so I will name it move 281 to root. Actually, shell .c. Okay, let's do it again with FTP using Django. I'm literally copying, boys. As I talk and type, I have problems. And this password that we store earlier. All right. Put shell.c. If you're like, hey, how do you know that it's a C file? Or it looks like a C file. Here's my shell.c, gcc. I need to find my syntax. I think it's just my dash output shell. I want shell.c to end up as shell. I think this should work. Don't quote me on that. ls. Oh, come on. I know my GCC syntax. Give me 1 second. Let me look it up. It always gets me every time. Okay. I have it backwards. GCC shell.c. I would like to output it to shell. Whoa, it doesn't like something here. Let's see. Let's see. Why is this happening? So something is failing in here. All right. But that's how you get GCC in there. Let me try to read the error here. Nah. Forget it. I have options. I can try to fix this. Or you name A. This you would have seen in also in the results. Let's see if this will actually give us something else as well. Here's another one. Ubuntu 16 exploit DB. We're going shopping, people. We're going shopping. We don't. This is another one. Okay, so here's what we're going to do. We're going to open that one and try to do it by hand. I like GitHub because people usually show you how things are usually done. And I also like to see examples. So on Hack the Box Academy, looks like there's a walkthrough here. Here's a kernel exploit, yada, yada, yada. It's the same exact thing. I bet if I run this command, I see the same thing. Ubuntu 16, Xenium. So we are in the right path. All right. So here's what we're going to do. I don't like this. But this is the idea. We have a shell script. If we get really desperate, we can use this one. But we're going to go to the source. Let's do it again with this one. Raw. This is some really fun stuff. I hope you like this stuff as well. Let's do it from here where we already did our FTP. You cannot copy and paste in FTP. It will not work that way. So let's get that on our Kali. I would like to move 450.10 to hect.c. Now let's get in with FTP using our credentials. Django 01. And let's paste. Put hacked.c. We are in, going back here. I am. I didn't put it in the right place. Of course, I can see it. It's in some directory somewhere. I'm going to say cd search home Django 01. I am not about to go and find it somewhere. I am just going to put it in the right place right away. ls. There is my hacked.c. Now let's try gcc hacked.c output. By the way, every time I say this word, YouTube demonetizes my YouTube channel. I don't get paid every time I say this word, by the way. So I don't know why I even do that. All right, there is our file code hacked. So now, if this works, this is a kernel exploit. There is no online kernel exploits, in my opinion. This is not the fancy way of breaking into systems. This is as easy as things can be. So let's see if this actually works. Yeah, it worked. So we actually got root. And here's our proof that we have. So the last part here, we were just going around and trying to really make things work. So you see that we could have fought the first one that didn't work, or we could have just moved on and we found this one here that worked. In fact, this is the usage, the GCC usage that they will tell you. So the question is, which is what we're interested in, are we actually going to be able to detect? This is a non-CVE, by the way. So does the Wazuh agent know about the CVE? And can we detect it? The answer is I don't know. We have to go and find out together. If we don't, I'll show you how we can set it up so that we can detect it. At the end of the day, that's what we are all about. We know how to exploit systems. We know how to detect things. So now let's go back to our system here. First, I'm just going to check by default. What did you see? Security onion. Let's refresh that. And as we do this, we get better. We know what we're doing. We become very efficient at just being able to check things. So this one says disconnected from manager. What happened here? Right. First, let's check the default alerts here. Potential. I like to check the ones from the Wazuh agent first. So I'll open them in a different tab. And our main interface here says we saw failed FTP authentications. We proved this earlier that this was us. But if you want to see, let's go and check out. Wow, these are all the sessions that opened. Every time we did like CD, LS, or whatever, this was opening a bunch of sessions for FTP. This will be noisy in a real production environment, by the way, unless if this is actually a real, important server. If you enable this on every computer in your network, you will get a ton of these. That's what I'm seeing here. Says, does Security Onion use metadata of the communication in order to figure out the action taken? No. On the victim, we're running a Wazuh agent or a Wazuh agent. We actually have a host-based intrusion detection system agent there. I'm also running audit D, but it's not connected to the agent. So I'm not sure if audit D events are making it here. but audit D should audit all the system events, and we can even set up logs there. But for now, let's just verify that this was actually us. So every time we interacted with FTP, things happened. So we know the user Django was doing that. That was us, and sessions were opened. In fact, to make it even more interesting, we can just come here and say, remember the file that I just moved? Let's see if we can see it. We should be able to see it because I put it using FTP via the network. So we should be able to see the actual file that we moved. Source was Kali Linux 192.168.186. Destination was the victim. And we should be able to see that it was a put command. I hope it shows me that it's a put command. There it is. This one said could not create file. We know we were able to put the file in there. So, but as you can see here, the user was Django, and the file hex.c was seen. Let's see if we can see a different event where it actually succeeded. Yeah, this one succeeded. By the way, this is when I put it in the wrong location and I didn't want to go and figure it out. So the last one should show me putting it in the user's home directory. This data is coming from the network. Actually, no, this is coming from the Wazuh agent. I lied. It sees it getting on the Django user's home directory. So our intrusion detection system is working. We know that we can, every time we move a file, especially using FTP, I mean, it's in plain text, so it will be seen. People can confirm that it actually got there. And it says status OK uploaded. I don't know if you can see it. You can't see it because it's right behind me. But if I move up, okay, it says status OK uploaded here. But that's not what we're really not after. We're after that privilege escalation. It really bothers me that we ran some random script from exploitdb and I'm not seeing an alert. That is a problem. And that's why I do these things, is because it's a known CVE. The Wazuh agent using the OSEC is actually just generating that. I don't see an alert for it here. That is an indicator that we have a problem and we need to fix it. So before we end this live stream, we need to talk about how could we have done it different to make sure that we detect that. Because right now, out of the box, detection is nowhere to be seen. This is how you get better at work, because you'll be doing this for your employer. You're trying to say, okay, where is our visibility gap? Where are we lacking? In this case, this will be a problem, and I'm like, it's a known CVE. We should be detecting that. Right now, nothing, okay? Let's see, back here. So that file hex.c was only seen moving across the network and also on the host. Who saw this? This was the Wazuh agent as well. And this was seen by Bro, I think. Yeah, this was a network event. FTP. This was seen by Zeek, also known as Bro. So we saw it in both cases from the agent and there. Okay, great. What about other indicators? I'm in the Security Onion Indicators tab here. All right, so that doesn't help us. Go back here to the actual alerts. File added to system. I think that was just us. All this here is nmap scan command not allowed, probably a sudo command that we ran. We'll see that. All right, now we're talking. Host-based anomaly detection. Maybe this is what we have been looking for. Let's find out. Successfully changed use ID. We didn't do that. So we'll find out. All right, I'll let it load there. So where are those here? Okay. So here's a root check, not rootkit. Let's check it on this interface. I switch between both interfaces depending on which one is going to give me the answers first. I really don't care. All right, I think we might be in business here. We might actually have found it. Because I was worried that we didn't do anything. So it looks like it's a possible kernel rootkit, as you can see here. This is what we triggered when we ran that kernel exploit, which is the Dirty Cow. If you haven't heard of it, that kernel exploit that we ran is usually known as Dirty Cow, and we did detect it from the Wazuh agent. So that's nice. And it's an anomaly. And it ran this process with the process ID right here at the bottom. So I think we should be happy that we did find this, because this was going to bother me all night long today without it actually matching. So that is what we see when we run the Dirty Cow for privilege escalation. So we can see it's right here. Is this ranked as high? Actually, it says low. That's interesting. That event is ranked as low. I would probably escalate that to be a high severity. But what did it see? Let me see here. So it saw a process here that got spanned by that, which is exactly how we wanted to do it. So if you haven't, please enable your host-based detection system. It does work wonders. And in this case, understand your environment as well. In this case, this will be getting a high priority from me instead of a low severity from the Wazuh agent. If you ever run Dirty Cow in anybody's environment, know that something like this might fire. I didn't actually customize this. I just left it out of the box, and as you can see, it did see it. So that was a big win for us. I didn't actually practice this, so I'm glad that it did find it. First time SU, this is when we switched user. File added to system. I like that. There's 7 files that were added to the system. What files? Okay, this is the Wazuh agent again. I don't remember these files. I don't know if these were part of the Dirty Cow privilege escalation or not. I can't confirm that. But it did add these boot config files here. Somehow, I have no idea where we added those files, but we generated that alert. Command not allowed. File deleted. I didn't delete any files. All right, let's see anything else. Unauthorized user attempted sudo. So this is when I tried to cat the password file, I believe. Why this will be classified as low, I have no idea. But if you look, this user tried to open the Etsy password with sudo, yet this is a low severity event, also coming from the Wazuh agent. So I don't know about you, but if this was a PCI compliant server and people were making mistakes like this, I'd like to know. It might remain as a low priority, but at least I would like some visibility into it, because it could be a bad actor trying to do that. But it's not a big deal if they failed. All right, let's see one more. We're getting a bunch of 400s. I'm not interested in these server errors. All right. I guess the final thing that we should check is our reverse shell. What does it look like? We didn't get an alert here that we got a reverse shell, but from the network perspective, zeek, and suricata, they should be aware of that connection when we did a 4242 connection. So we should be able to just come here, maybe destination.port or 4242. Or source port of 4242. I just want to see our reverse shell. You gotta be kidding me. We did get a reverse shell. Let's track it down on the main dashboard. Maybe we should try the hunt interface. It's there. Let me just open a clean Kibana page. We should find a connection from our victim to Kali on port 4242. And that is something that we know for sure. I probably was in the wrong section. And while that is loading, let's check other things as well. Yeah, these are the same events. Here is a summary of all the things that we generated. User generated error. We generated a ton of errors. And this is from the Security Onion Wazuh interface. This low relevance attack, I don't think we checked it last time. All right. My Security Onion is a little slow today. It should be faster than that. So Wazuh is not going to see 4242 for sure. That's a network connection. So what I would just do is I'll just search for 4242. Oh, you know what? I just coded. When we got our reverse shell, we URL encoded it. So when you URL encode, dumb tools like Zeek will not be able to see that traffic. So maybe we won't be able to see 4242. Let's try again. Yeah, maybe I lied because I see it here. So help me understand this. URL encoding gets seen. Because I see it right here. It doesn't tell me what happened, but I see the source and destination. Connection established, not terminated. So this shows me that the destination was my Kali Linux. Destination port was 4242. The only transactions that happened tonight on 4242 in this network were that reverse shell. So URL encoding is not encryption. It's encoding. you will be seen because we get an S1 connection state. That's something to learn as well from tonight. Awesome stuff. I'm telling you, this is really, really awesome stuff. So some of these would have failed because we tried a couple of times. All right, so there you have it. This is our reverse shell. We confirmed that we can see Dirty Cow attacks because it shows here as a rootkit on the system. We got one event. And we also see that, you know, when we ran the command ID, we also got busted here. This is a classic. If you get on a new system and you type ID, you get caught. Actually, I guess this is a good place to end. Remember what we did here? This is our exploit that we actually executed, by the way, the Dirty Cow exploit. It's showing in our intrusion detection system here. This was actually caught by suricata. So everybody caught something today. Zeek caught the connection. Wazuh agent saw this rootkit. And suricata actually did catch the actual Dirty Cow exploit, including a link to a GitHub page and some comments about it. You can't make this up. This is how you get busted. So we got it working, and this is really great stuff. So if you like this, please remember to like and subscribe. If you have any questions, let me know in the comments. I will be happy to answer them, but this is really exciting stuff. BT has a question here. Says, did you see the command you encoded? Yeah, I was curious if we have the encoded command somewhere. That will be from Zeek on the network connections. But I'm glad that we did this because, geez, look at this stuff here. This is the actual part of the exploit. And in fact, it generates a socket, and that's the socket that got caught by that other alert. So when we do this, capture the flags from hack the box, found hub, you know, try hack me, this puts everything in perspective, really, why we do this. Someone says, so if any GitHub action on network, pull the plug. I don't know about that. If you see any GitHub pulls, most companies actually have policies defined in their firewalls that say, you know, if somebody pulls something from GitHub, they might know about it. For sure, for data loss prevention, if you push something to GitHub, the public GitHub, some big corporations would know about that. All right, so that was it for us. I'm glad that you were here, and thank you very much for being here. I hope you like and subscribe to this video. Otherwise, I'll see you next week where we'll be doing something similar to this, something really exciting and fun. And thanks, and have a good night.